Just a quick reminder before we get into the lesson to download the hands-on lab exercises that accompany this complete CCNA course. I'll include the link in the description. Also remember to subscribe and hit the notifications bell so you don't miss any of the lessons in the course. Okay, let's get into it. In this lecture, I'm going to configure default routes and also load balancing in the lab. It's the same lab setup as before. We've got our routers R1 to R5 and our PC1, PC2 and PC3 clients. Right now in the lab, the routers have all been configured with their IP addresses, and we've got static routes between all the different subnets. There's just one interface that hasn't been configured yet, which is on Fast Ethernet 3/0 and R4. We're going to configure that with a public IP address going out to an internet service provider. So R4 is going to get IP address 203.0.113.1, and the next hop out to the internet is at the service provider at 203.0.113.2. So let's configure that now. So I'll go on to R4. If I do a show IP interface brief, you see I don't have that internet interface configured yet. So I'll go to global configuration, and then it was interface fast 3/0, and the IP address is 203.0.113.1, and we'll use the normal /24 for our lab example, and remember to do a no shutdown on the interface. Okay, so that is our interface configured. Let's just check that it's come up. So we'll do a do show IP interface brief again and try to spell brief correctly. And there we can see that Fast Ethernet 3/0 is up. So that's good. Next thing to do is to add a route going out to the internet. So obviously this is going to be for all traffic, everything that isn't for our internal networks. So the way that you configure a catch-all or a default route is IP route, and then it's for 0.0.0.0 and a subnet mask 0.0.0.0. This is going to catch everything that does not hit a longer prefix or a more specific match route. And the next hop is at our service provider, which was at 203.0.113.2. And if I now do a do show IP route, I can see that the gateway of last resort has been set to the service provider at 203.0.113.2, and there is our static route. It gets an asterisk at the end of the S to indicate that this is the default static route. So that is R4 configured for now. Let's also configure default static routes on our other routers as well. So if we go back to the topology diagram, R3's next hop, again, it doesn't have direct connectivity to 203.0.113.2, so its route is going to point at the next hop address of 10.1.1.1. So let's configure that one next. So that was on R3. I'll go to global configuration and add a default static route, so 0.0.0.0, and the next hop there was 10.1.1.1. I'll do a do show IP route to verify again. I can see that the gateway of last resort is set to the next hop, and there is the default static route. Back to the topology again. Next one we'll do is R2. It's going to have a next hop of 10.1.0.0. So back onto the lab again and onto R2, global config, and IP route 0.0.0.0, 0.0.0.0, a next hop of 10.1.0.1. And you know the drill already. I'll just verify again. I forgot to put the do in at the front there because I'm not at exec mode. And there is the default static route added fine there as well. And then we'll do R5 next. Let's just check what its next hop is. So R5, to get out to the internet, its next hop is 10.1.3.1. So R5 next, config t, IP route, o.o.o.o, next hop 10.1.3.1, and verify. Okay, so that is, if we go back to the topology again, R4, R3, R2, and R5 all configured with a default static route going out to the internet. On R1, I'm going to configure it with two different paths to get out. I'm going to configure a path via R2, and I'm also going to configure an other route via R5, and then the router will load balance between them. So when you want to do load balancing, the route and the prefix have to be exactly the same. For example, 0.0.0.0 and 0.0.0.0. Or if I was doing a route to get out to the 10.1 networks behind R4, I could have 10.1.2.0/24 for both routes, one going to R2 and one going to R5. But if one of them was a /16 and one of them was a /24, that wouldn't work. Okay, so the destination you're routing to and the subnet mask have to be exactly the same on your routes to be able to do equal cost load balancing. So let's do that on R1. So I'll go on there, go to global configuration, and I'll do an IP route o.o.o.o and a mask of o.o.o.o, and I'll do the first one going out via R2, so that was the next hop of 10.0.0.2, and then I'll hit the up arrow to do another route but going via R5, and that was at 10.0.3.2. And if I now do a do show IP route, I should see both of these showing up in the routing table. So there is my default static route, and I can see it's going via both of the next hop addresses. So the router will load balance the outbound traffic via both of these. So going back to the topology diagram again, that means that traffic from my PCs is going to be load balanced over the two paths. However, if we look on R4, I'm not doing load balancing on there yet. So I'll verify that first. And then what I'm going to do is I'm going to do two routes from R4 getting back to the 10.0.1 network and the 10.0.2 network. I'll send one via R3 and I'll send the other one via R5. So on R4, let's do a do show IP route. And I was looking for the 10.0.1 network where PC1 is, and it's going via 10.1.1.2, which is on R3, and 10.0.2, I've also got a single route for that going via R3 as well. So let's add a couple of routes here. So IP route to 10.0.1.0, 255.255.255.0, and I'll send this via R5 at 10.1.3.2, and I'll do the same also for the 10.0.2 network. And if I do a do show IP route now, I'll see that I'm load balancing on those 10.0.1 and 10.0.2 networks. So if we go back to the topology diagram, traffic going out to the internet from PC1 and PC2 should be load balanced over the top and the bottom path. So let's go back to the command line to verify that. So I'll go on to PC1. Now, I don't actually have internet connectivity in my lab here, so I'm not going to be able to ping an address on the outside, but I'll be able to verify the path as far as R4, and I should see half of it going over the top half and half of it going over the bottom path. So let's verify that. So from PC1, I'll do a trace, and I'll just make up a public IP address. So let's do a trace to 50.50.50.50. And I see that that is going via 10.0.3.2, which is R5 on the bottom path. So I'll break out of that, and I should see the other half of my traffic going via R2, which is at 10.0.0.2. But let me tell you the way that the load balancing algorithm works as well. If I keep doing a trace between the same source and destination, you'll see that it is always going to take the same path. So from PC1 to 50.50.50.50, it's always going via R5. The way that the load balancing algorithm works is it's based on a hash between the two different hosts. So traffic from one host to another host between the same two IP addresses, the same ports, is always going to go over the same path. The reason for this is that it's not going to do round robin load balancing for the same flow. So say that my PC1 host was accessing a web server at 50.50.50.50. I don't want that traffic for the same flow to be going over two different paths, because it could cause the packets to arrive out of order, and that could cause problems for my application. So the same flow will always go over the same path. But if I do a trace to a different IP address, there's a 50-50 chance it will either go over the same path or a different one. So I'll just go up one IP address, and now I can see that when I'm going to a different IP address of 50.50.50.51, it is going over the top path, which is via router R2. Okay, so that's how to configure our static default routes and also how our load balancing works. See you in the next section. Thanks for watching. If you'd like to get the complete course ad-free right now, then you can enroll in my CCNA Gold Bootcamp by clicking the link above my head or in the description. It also includes full study notes, quizzes, and 150 pages of additional troubleshooting labs you can't find anywhere else.